So this is on page 12. We're going to take derivatives of inverse trig functions and as well as logarithmic functions in this video. So here's a whole whack of more derivatives you need to memorize. These are they have similarities between each other. It's always going to be a rational with a 1 in the numerator. And then we have some variation of 1 and x squared in the denominator. You just need to find patterns to help you memorize. So when you think of sine inverse x and cos inverse x, the derivative of those are quite similar to each other, except they have a different factor of -1. Versus tan and cotangents are similar, and they too have a different factor of a -1 in the numerator. And then secant inverse x and cosecant inverse x look the same, except again with that factor of -1. So really you have to memorize 3 and then just remember which ones are related to each other. That would be the best way to go to memorize these ones. So to take the derivative of these guys here, in example 1, we need to use our chain rule, just like before, because we have a function, sine inverse of x squared. So when we take the derivative of this whole function, we need to break it down by taking the derivative of the outside function first. So my outside function is sine inverse, and the derivative of sine inverse is 1 over root of 1 minus x squared. Now, we won't write x squared, we're going to write what we see in the bracket, which is x squared squared. So the derivative of sine inverse is 1 over the root of 1 minus, and then whatever I see in that bracket, squared. Okay, and then now take the derivative of x squared, and that'd be 2x. You bring the 2 down, and then you minus 1 from the exponent. And that's it. You don't need to simplify this, just leave it as is. For the next one here, I'm going to change this maybe into an exponential. So instead of having the 5th root, we can write it to the power of 1 over 5. And then right away we can see that we can use our power rule as a part of our chain rule. So my outside function would be to use my power rule. So this will be 1/5 of whatever's inside the bracket. And then that's minus 1 from 1 over 5, which is the -4 over 5. All right, so now I'm going to take the derivative of the inside of my bracket. The derivative of 2 is just 0, so that's gone. The derivative of tan inverse x is 1 over 1 plus x squared, and there was a negative coefficient at the front, so we just stick it at the front as well. And that's it. There's no more function on the inside here. This was just x. So that's it for that one. Go ahead and try the next 3. So I want to pause this video and try the next 3. Okay, so for y equals cos inverse tan x, again, we'll use a chain rule. My outside function is cos inverse, and the derivative of cos inverse is -1 over 1 minus, and then whatever I see in the bracket, which is tan x squared, and this will all be under a square root. Okay, and then now take the derivative of tan. My derivative of tan is sec squared x. And then that's it for that one. For D, I'll take the derivative of sec inverse, which is 1 over, usually would be x, but we're going to put whatever we see that's in the bracket. So this would be root x. And then there's usually x squared minus 1. The squared will cancel with our roots, so we're just left with x minus 1. And then I'll take the derivative of the root x, which would be 1/2 x to the -1/2. And we can just leave it like that. This one's a little bit more nasty. It's not supposed to say f prime here, sorry. Unless we're trying to find double prime, I guess that wouldn't be a problem. So the derivative of this one, we're going to take the derivative of sine and then cos inverse and then 2x. So the derivative of sine will be cos, and then we'll write whatever we see in that bracket there. And then we'll take the derivative of cos inverse, which is 1 over the root of 1 minus whatever we see in the bracket, in this case is 2x, and then square it. And remember there's a negative in our numerator for that one. And then now we'll take the derivative of 2x, which is just 2. And you can just leave the answer as is. Okay, moving on to logarithmic functions. Now here's another T you need to memorize. The derivative of log with base a of x is 1 over x ln a. So x would be whatever you would see. That would be in the bracket for log. And then a is always going to be your base. D over dx for ln x is just going to be 1 over x. The ones are really easy to use, and you're going to see it time and time again. So the derivative of ln x is just 1 over, always going to be 1 over whatever you see that's going to be in the bracket. So let's try to apply these. So we have 1 over, and then whatever you see in the bracket. So in this case is sec x, and then ln my base, which is 3. Now take the derivative of sec x in conjunction with my chain rule here, and that'll be sec x tan x. And then that's it. The next one, so for ln will be 1 over whatever we see in the bracket. So this will be 1 over cos x. And then we'll take the derivative of cos x, which is minus sine x. And actually we can just simplify this. It's not a big deal if we do it. This will be minus tan x. Remember that identity of sine x over cos x? That's the same thing as tan x. This last example here, we have ln of ln x. So we'll start off with 1 over whatever we see in the bracket. So it'll be 1 over ln x. And then we take the derivative of ln x, which is 1 over x. That's the same thing as saying 1 over x ln x. So now here's another few that you could try on your own. You may pause this video to do that. Okay, so the derivative of y equals ln and 9x. The derivative of ln is 1 over, and then whatever you see in the bracket. And then multiplied by the derivative of 9x, which is just 9. 9's will cancel out, so you're just left with 1 over x here. The next one, ln of tan e to the x. So we'll take the derivative of ln, which is 1 over whatever we see that's in the bracket. That's tan e to the x. And then we'll take the derivative of tan. Derivative of tan is sec squared. And then we'll put in whatever's left in that bracket. And lastly, we'll take the derivative of e to the x, which is just e to the x. And that's it. Our next one here, we'll have to take the derivative of the outside function, which is log. So that would be 1 over whatever we see in the bracket times ln of your base. So I'm going to write whatever I see in the bracket, which is cos of x minus x over 2 minus 2. And then we'll do ln of our base, so that's ln 10. Now I'm going to find the derivative of cos. Derivative of cos is minus sine, and then I'll still put in whatever was in the bracket there. And then lastly, I finally get to take the derivative of the very inside, so that's x over 2 minus 2. And the derivative of that would just be a half. Remember that x over 2, you can just take the coefficient to the front, so that's the same thing as saying 1/2 x. And the derivative of x is 1, so you're just left with a coefficient, which is a half. And then you just leave your answers like that. The last example. We're going to take the derivative of log 3. So that's 1 over whatever we see that's in the bracket. So that's tan inverse 1 minus x. And then ln of our base, which is 3. Then we're going to multiply it by the derivative of tan inverse. That would be 1 over 1 plus whatever we see in the bracket squared. So this will be 1 minus x squared. And then we'll take the derivative of 1 minus x, and that will just be -1. And then that's it for that one. So that's all for today's notes. You can go ahead and try the homework problems that's listed below.